Hey guys, day 3 of factoring. We're going to start with learning how to factor out a negative number, and then we're going to do just a couple of review for greatest common factor, factoring that out, and factoring with just a rational number like we did yesterday. So when you factor out a negative number, the number that you factor out is negative. It could be just, 2, it could be 27, it could be 5.2, all negatives though. It could be negative 1/2. As long as it's negative, you are factoring out a negative number. So I'm going to talk you through my thought process here, and when I'm talking through this is how I solve every problem. This is what I say to myself in my head every time I come across one of these problems. So for number one, or for this one, we're going to factor a -2 out of -4p plus 10. So first, what I think is that we're going to write each term as a product of -2 and another factor, because you need two things to multiply together to get our number. So I'm going to think 4p is -2 times what? So I look at 4p, so when I look at -2 comparing to -4p, I have a negative there, and if you remember, a negative times a negative gives us a positive, and since our answer is going to be negative, we know that this has to be positive, because a negative times a positive gives us a negative. So then we notice that -4p has that variable, that p, so our answer here will have to have a p on it. And now what's left over is just 2 times what will give us that 4? Well, 2 times 2 gives us 4. So -4p is -2 times what? It's times 2p. Now I need, because I have -4p plus 10, I need to look at 10 is -2 times what? Because I'm trying to figure out both of these factors. I'm trying to get that -2 out of both of them. So 10 times, -2 times what gives us 10? So again, a negative times a negative will give us that positive, so this is going to be a negative in our answer. And 2 times what gives me 10? Well, 2 times 5 gives me 10, so -5. So next I'm using the distributive property to factor out that -2, and this is kind of the same step that we did with our rational numbers, where we just rewrite things and we're moving our terms around. So I start with my -4p plus 10, and I'm going to change it. I'm pulling out the -2 from both of these factors. I have my plus sign in the middle, so -4p is going to be over here, 10 is over here. When I pulled out that -2, I was left with 2p. So right here I'll have 2p. When I pulled out the -2 from the 10, I was left with a -5. So -5 right there. And now I'm using that distributive property to rewrite as simply as I can, because I don't need to say -2 twice, so I'll have it over here. And then I write whatever's left over inside of my parentheses. So I have the -2. I don't have the 2p yet. I need a plus sign. I have my -2 out here, and I have a -5. And the only thing that we can do to simplify this even more is to say that 2p plus a -5 is the same thing as 2p minus 5, because plus a negative is just subtraction. So -2, oops, I forgot my p. So -2p times 2p minus 5 would be my answer. Alrighty, let's find the next board here. The next example is going to be factor a -5 out of -5d plus 30. So you'll notice I kind of took away my written out rules, but I'm still going through that thought process. So I'm thinking, I start with pulling out a -5, and I have to write in my two factors here. So my first factor is a -5d. My other factor is a 30. And so now when I take that -5 out, -5d, and I could say divided by -5, you know, a negative times or a negative divided by a negative gives me a positive. So our answer will be positive. And then 5 divided by 5 gives me 1. D, there is no D here, so we'll have D. And, you know, just thinking the way that we were in the last problem, another way to say that would be -5 times what gives us -5d. Well, we have our -5, and so since 1 times anything gives us anything, we know that this has to be 1 because I want to keep that -5 as a -5, but I need to add that d in there. So I'm just going to add a d and multiply by a d. So over here we have -5 and a 30. So what do I need to multiply that -5 by to make it a 30? So a negative times what gives us a positive? A negative. It's a little slanted there. Okay. Negative times a negative gives us that positive we need. And now 5 times what gives us 30? 5 times 6. So then when I move down here, I start with my original expression, -5d plus 30. I have my -5's that I factored out. And then from what I thought about up here, when I factor the -5 out of -5d, I am left with 1d. When I factor out a -5 from 30, I'm left with -6. And now since I moved my -5 out on the outside of my parentheses, I fill the parentheses with whatever's left over in this little sentence right here. So that's going to be a 1d plus a -6. And again, I can simplify that by just saying that -5 times 1d, and then change that plus a negative to a -6. But it, you know, it's not really simplifying that much more. It's just changing that plus a negative to a minus because it's the same thing as subtraction. Alright. Factor a -4 out of -8k minus 12. So when we think about this, we're going to say our first factor is -8k. Our second factor is -12. I'm factoring out a -4 from both of them. When you factor, you're always going to multiply here on this side. You're not going to divide or subtract or anything. You're always going to multiply because you want to know what two factors, so what two things that are multiplied give you this product. So right here, when I need to multiply -4 times what gives me a -8k. So we have our variable here, we have a k here, we don't have a k here, so we know we need a k. Now let's look, we have a negative and a negative. So negative times a positive gives us our negative, so we know this has to be positive. Now 4 times what gives us 8? Well, 4 times 2 gives us 8. Here we have -4 times what gives us -12. There's no variable in either of these terms, so we don't need to worry about that. We have a negative here, we have a negative here, so we know that our answer needs to be negative. So a negative times a positive will give us that negative. Now it's just 4 times what gives us 12, and it's 4 times 3 gives us 12. I know I'm going through these a little fast, but keep in mind you can always go back and rewatch a portion of it. You can rewatch the entire Edpuzzle, or you can come ask me questions. So now we are gonna rewrite -8k minus 12. So we pull out our -4 because we were factoring out a -4. From negative 8k, we factored out a 2k. From negative 12 or minus 12, we factored out a 3. Yeah, that's another thing if I didn't mention it already. When you are factoring, and there's a minus sign here, keep it with the term. So if you have a negative 12 or a minus 12, it's a negative 12. And then if it's a plus 12, then it's a positive 12. Alright, but back to this. So we pulled our negative 4's out, so then we are left with 2k minus 3. Actually, since I called this negative 12, we're going to call this plus 3. Because that would change. I don't like that. Okay, because calling this negative 12 makes our expression look like this. Negative 8k plus minus 12. Remember, I've been rewriting our answers at the end when they look like this to say negative 8k minus 12. Well, that's just what this is, and so I have to rewrite it when I use it as a negative 12 right here to say plus a negative 12. So then my answer will be a plus 3. Alright, so for this one, 12n minus 24, I'm going to show you how you can solve it all three ways, using the greatest common factor, using a rational number, and using a negative number. Well, I should make one of them negative then, shouldn't I? Here. Negative 12n minus 24. See, trial and error, we'll get through this. Alright, so, no, that won't work. I'm sorry, y'all. We're going to use this one for the first two ways, and then we'll make it a negative for the last one. So for greatest common factor, we need the greatest common factor of 12 and 24. So our factors of 12 are 1 and 12, 2 and 6, 3 and 4. Alright, so since there's no number in between 3 and 4 besides like 3.2, 3.5, 3.6, there's no other factors of 12. We've found them all. So 24 is our other factor that we got to figure out. 1 and 24, 2 and 12, 3 and 8, 4 and 6. I wasn't really lined up there, but it's okay. It'll work. You can still see. So now the greatest common factor between the two of them, let's see. Well, common factors, we have 1, 2, 3, 4, 6, and 12. So 8 and 24 are not a factor of 12, so they don't count for common factors. So the greatest common factor is just the largest of 1, 2, 3, 4, 6, and 12. So our greatest common factor here is 12. So now I'm pulling a 12 out. And when I do that, this first factor, I'm left with a 1n, because 12 times 1, but we keep that n because we're not pulling the n out because there's no n over here. Subtracting up there, subtract down here. So when I pull out a 12 from our 24, 12 times 2 gave us 24, so it'll be a 2 inside of the parentheses. Now we bring our 12 all the way outside, and in our parentheses we have whatever's left over, so that'll be 1n minus 2. That's our answer. So now if I did this using the rational number method, we're just gonna pull out a rational number. Well, 12 is a rational number, 6 is a rational number. 4 is a rational. You can kind of take your pick here. But, I mean, our goal is to get this first number as small as we can get it. So I'm going to use 12. That's kind of my thought process behind this. So if I have 12 as my rational number, and I say 12n minus 24. I say 12 goes into 12n 1n times. 12 goes into 24 2 times. And remember, when we did this yesterday, we did it with fractions. And so I wrote out like 12n equals 12 times what? And, sorry, that should be 24. Right here. 24 equals 12 times what? And that's how I get my 1n and my 2 when I start with pulling out the 12. Because remember, if I'm doing it this way with the rational number, I have not done the greatest common factor. I don't know it. You know, not off the top of my head, I haven't done that yet. So then I go ahead and pull out the 12. And I have 1n minus 2 left over. So remember, either way I did it, whether I did the greatest common factor or I did the rational number, I get the same thing. Alright, last way I'm going to use a negative number, but I'm just changing it to a negative 12n minus 24, so that way I have that negative number. It's still the same kind of generic problem, but let's see how this affects it. So, if we think negative 12n equals, let's pull out a negative 12 times what? Negative 12n equals negative 24 equals negative 12 times what? So right here I get a negative times a positive, gives me that negative, so that's going to be a positive 1n. Negative 12 times what gives us 24? Negative times a negative gives me a positive, so that'll be a negative 2. And then I can rewrite it so that it says negative 12 times 1n, and then it was a minus in the problem, so it'll be a minus down here, minus a negative 12 times negative 2. Lots of negatives in this one. So now if I pull out my negative 12s, I'm left with negative 12 times 1n minus a negative 2. So the only thing I can do to simplify this anymore is to say that minus a negative here is adding. So negative 12 1n plus 2. And so adding that negative on the outside of our initial problem, you'll notice just changed our sign on the outside at the end here, because it was, when we started with a positive, we ended with a positive 12. When we started with a negative 12, we ended with a negative 12. When we started with a positive, we had subtraction. When we started with a negative, we had addition. Just some interesting things to see there. Alright, I want you to try this one real quick on your own, but we're going to actually do practice with all three tomorrow. So go ahead and try this real quick. Okay, so now that you've tried it, we're going to factor the negative 8 out of negative 32d plus 56. So we know we're going to have a negative 8 pulled out. I'm doing this wrong already. So negative 32d is equal to negative 8 times what? Well, negative times a negative would give us a positive, but that's negative. So this is going to be positive. 8 times what gives us 32? It's going to be 4. And since there's a d here, but no d here, we need a d with this term. So then we have 52 is equal to negative 8 times what? Just kidding, it's 56. 56. Okay, negative 8 times what gives us 56? And it's 7. And it's actually going to be a negative 7 because a negative times a negative gives us a positive. Right? So now we can write it as negative 8 times 4d. And we were adding up here, so we'll add down here. So it's plus a negative 8 times that negative 7. And now we're going to pull our negative 8's out. So negative 8. And whatever's left inside, so 4d plus negative 7. And now rewrite it so that it is a little bit easier to read. We have negative 8 times 4d minus 7. But if you had written it like this, I'll accept it for now. But you should get in the habit of writing it like as simplified as you can get it. Alright, once again, if you need some extra practice, I suggest using some of the IXL lessons under level I, problem set R. I don't know how else to describe it, but they're all labeled R. I think it's expressions and something about expressions. It'll say R something expressions. These 5 I kind of suggest, but if you want to start with any of them under there, that's fine. If you need me, let me know.